definition of a square root, we have the radical sign. Underneath the radical sign is called the radicand, so this little a. And then we have the expression underneath. So what we're going to do is we're going to reduce some of these square roots. So think about 64, the square root of 64. You can break that down as 8 times 8. And now we have an index of 2. So we have our pair, so the square root of 8, or square root of 64 is 8. All right, part B, negative square root of 49. 49 can be written as 7 times 7 with a negative out in front. So we get negative 7 as a solution. Square root of 1/4. You can rewrite that as 1/2 times 1/2. Now we have our pair. So the square root of 1/4 is 1/2. Square root of 9 plus 16. What we can do is we can add 9 and 16 together to give us 25. The square root of 25 is 5. Square root of 9 plus the square root of 16. What we have to do with these, we have to simplify them separately. So the square root of 9 is 3 times 3. Square root of 9 is 3. Same thing with 16. 16 can be broken down to as 4 times 4. Square root of 16 is 4. And now we can add these two together. 3 plus 4 is 7. All right, we'll continue on. What we can do is we can use the product rule for square roots, where if we have a product underneath the radical, we can separate out into 2 radicals, or opposite, if we have 2 radicals that are multiplying and they have the same index, we can multiply them in underneath as 1 radical. So let's go ahead and do some examples here. The square root of 500. We want to think about how can we break down 500 into a product of 2 numbers. So 5 and then 100. So 5 times 100 is 500. How that will help us is we now are going to have a perfect square with 100. This can be the square root of 5 times the square root of 100. Think about what is simplification of square root of 100. That's 10. Now that's kind of different. I would say put your 10 out in front and then leave your radical at the very end. And that's the most simplified you can go. All right, part B, the square root of 6x times the square root of 3x. We can combine those together as 6x times 3x. Now we can simplify 6 as 3 and 2, and then we have another 3 underneath, and then x and x. Now we're looking for pairs. So we have a pair here, so that 3 is going to pop out because the square root of 3 times 3 is square root of 9. Then we have another pair here. So square root of x times x is x. Now what will stay underneath is anything that's not a pair. So that's 2. Quotient rule for square roots. You have a radical with a fraction underneath. You can separate out into 2 radicals with division, or opposite. If we have 2 radicals dividing, we can combine them back together into 1 radical. So we'll do some examples here. All right, square root of 100 over 9. We can break this up as square root of 100 over square root of 9. So 2 radicals. Now let's look at those. They're both perfect squares. The square root of 100 is 10. Square root of 9 is 3. So it reduces down to 10/3. All right, part B. We have 2 radicals, and we want to simplify them. So sometimes it's better to combine them back into 1 radical. So 48x cubed over 6x. Now, see if we can simplify 48x cubed over 6x. So we'll go underneath and we're going to cancel out an x. So this now becomes an x squared, and that x is now just a 1. Now we think about, can we reduce 48 and 6? Yes, we can. This reduces by 6. This will become an 8, and this becomes a 1. So underneath now we have 8x squared over 1. All right, now let's see if we can break it down some more. So we have the square root of 8x squared. I'm going to break down 8 as 4 times 2 and then x squared. Again, we're looking for pairs. Is square root of 4 perfect? Yes, square root of 4 is 2. Is square root of x squared a perfect? Yes, so that pops out to be an x. Now this 2 is not a pair. It's not a perfect, so that has to stay underneath as square root of 2. I think we'll stop there.